Hi, everybody. Another round of questions and answers from general or introductory chemistry. So the first question I have here is, what reaction products are expected? They're asking reaction products from this reaction. C6H12 plus O2. First, recognize this is a hydrocarbon. Carbon and hydrogen are the only elements. Reacting with oxygen, it gives out carbon dioxide and water. In this question, they don't ask you to balance it, but it's good practice. Try to balance this. So we have 6 carbons here, so I put 6 carbon here, and 12 hydrogen, so I put 6 here, then 12. Then total of oxygen here is 12 and 18, so I put 9 here. It's balanced. You don't have to balance it. Because of this question, they're asking, what are the products? So whenever hydrocarbon burns in oxygen, it gives out carbon dioxide and water. The next question is, classify the reaction. So you have to check your notes on classification of reactions. Here, magnesium plus 2 Ag NO3 silver nitrate in 2 Ag plus MgNO3 twice. So what is it? You can see that magnesium has replaced this silver. That's why silver is alone here. So this is a replacement. Only a single atom has been erased, so you put single replacement. All right. Okay, so the next question here is about the molar mass of Mn2O7. Okay, now, so all you do is periodic table here. You find that mass from the periodic table. Take it as the grams value. So manganese is 5494. Let us say manganese. I will take manganese as 55. Round it up. So we have 2 of that, and then 2. So it will be 55 times 2. That's 110. And we have 7 oxygens. So that is 16 times 7. That's 112. So I get 222 roughly. So that's grams. Okay. How did I get these 2 values? From the periodic table, not the lower number, but the higher number, which is the mass. The mass is given by the number of protons and the number of neutrons. But for the molar mass, you simply take that mass and put a gram. So make it a gram. So it's the molar mass. That's the easiest way to remember. All right. Okay. Another question on. All right. Now, question, let me write it. So how many moles of oxygen? Okay, so let's check. I will write exactly as they're asking because it's not O2 there. How many moles of O or oxygen are available in 2.25 moles of Cr2SO4 dichromium sulfate. Okay, so when you have 2 things, you know that sulfate must have had the 2 minus 3 here, must have been in chromium. Okay, if you're naming, then chromium should, if you're naming it to be chromium, should have 3 Roman numerals. So just try to connect what you have learned so far. But that's not the question here. It's good. The question here is how many moles? So they're given the moles and they're asking how many moles are there. Okay, so let us separate it. There are 2 moles of chromium here, plus Remember, there's 3 here. So 3 moles of sulfur plus 3 and 4, 12 moles of oxygen. So in 1 mole of this compound would give 12 moles of oxygen. Then 2.25 would give, just multiply by 2.25. Okay. So I get 27 moles. Remember, it's 4 oxygen, okay, not 12. This is not 5, this is sulfur. This is chlorine, okay? So 27 moles. That's how we get the answer. All right, the next is, I will just put the question mark and grams, so that means how many grams they're asking. Earlier they asked moles. Now he's asking how many grams, this is the question mark, of boron are present in B10H40. Okay, now they just asked, in 3.5 moles B10H40. Now they're asking the grams. They're not asking the moles. Okay, so whatever it is, we have to see, because they're asking grams. If you take 1 mole of B10H14, in there, how many grams of boron there? We don't have to go for the moles, you can just say grams, that's easy. So there are 10 boron atoms, right? 10 boron atoms and 14 hydrogen. Okay. So there are 2 ways of doing it. Okay, I'll talk about both ways. So there are 10 moles and 14 moles. Let's go by moles first. 1 boron B10H14 has 10 boron moles. So 3.4 would have 3.5 moles would have, you multiply it by 10, you get 35 moles. But they're asking grams. Then find the boron mass is 10, is 11. So the mass of boron is 11. Therefore, we multiply by 11. Here 385, but the answer here is 378. Because if I didn't make it, 10 something, then I will get more that. So that's the answer. Okay. Now the other way of doing it, this may be an easy way. B10H14, 1 mole, you can see the mass of boron there. You can get the molar mass and the mass of boron, and then multiply by the moles value. So if I'm going to see the molar mass of B10H14, it will be 35 times 10 plus 1 times 14. Okay, so 350, 364 grams. That's the molar mass. Okay, so in 1 molar mass, we have 10 boron, right? What is the mass of that? 350. So we get 350 grams in 1 mole. But they're talking about, sorry, we get 35 grams. Just place it here. Okay. So let me do it again. I'm sorry. So B10H14. So let us get the molar mass of B10. It will be boron is 11. 11 times 10, 110 for boron. And for hydrogen, we have 14. 1 times 14, 14. So we get 124. So 124 grams is the molar mass of boron. So in this 124, you get 110 boron. Right? Now, next thing is to find the mass of 3.5 moles. So 3.5 moles mass would be 124 times 3.5, 434 grams. Okay. So here you can take this as a percentage if you want. Let me do the percentage. So out of this 124 grams, in 1 mole, 110 was boron. So the percentage of boron in that is 110 divided by 124 times 100. So 110 divided by 124 times 100. 88. So 89% is boron. So this 434 grams should be 89% boron. 434 times 89. Let's see. 89 times 434. 386. Right? So can you see both are same? So both methods the same. Here, this is the easiest, but this is, if you know what you're doing, so this is okay too. Okay. All right. In how many grams of fluorine in 400 grams of UF6? So they have given the molar mass of UF6 as 352. So how many grams of fluorine? So we'll go by the easy method. So UF6 has 1 mole of U and 6 moles of F. So if it is 400 grams, now this time it's not the moles. So we will take the molar mass, which they have given 352. But out of that fluorine, only 6. So fluorine mass is 19. So 19, we have 6 of it. So 19 times 6, I get 114. Okay, 114 grams. So 114 grams in 352. Percentage of fluorine, this is the percentage of fluorine is given by 114 divided by 352. 32.4%. Then fluorine should be 400 times 32.4%. I get 129.6, we say 130. 130 grams. Okay. If in 1 mole of UF6, we have 1 mole of U, 1 mole of fluoride, right? Sorry, 6 mole of fluoride, 1 mole of uranium, and 6 mole of fluoride. So 6 mole amounts to 19 times 6 means 114 grams. The molar mass of UF6 is 352. They have given it, or we can calculate by finding the uranium mass and 6 times of the fluorine mass and adding them together. So out of 352, 114 grams was fluorine or fluoride. Then when you multiply by 100, you get the percentage as 32.4. So whenever they give a mass, that 32.4% of that mass has to be the fluoride mass. Next one is, okay, so gradually the change in this way. So the question is, how many molecules now of CO2 are present in 35 grams of CO2? Okay, so molecular mass of CO2 is given as 40.1. I'll take it as 40. Okay, so first of all, 35 grams. You have to find how many moles are there, then convert it to molecules. That's what you do. So the normal equation, mass divided by mass equals number of moles. So 35 grams divided by 44. 35 divided by 44, I get, it's a 0.8 moles. Okay, round it up. 0.8, yeah, 0.8 moles. Now, go back to Avogadro number. 1 mole has 6.02 times 3 molecules. Okay, so because it's 0.8, .81 to the power. So that's how we do that. Next one. Now they're asking not molecules. How many atoms of chlorine in 200 grams of Si3Cl8? Okay, they have given the 200 gram. They have also given the molar mass of Si3Cl8 as 367.9. Let's go for the moles. Let's go for the molecules. We do one by one. Okay. How many atoms? So 200. I'm going to go through again. 361.9 because the molar mass. I need not to explain these things again. 367.9. I get 0.54 moles. Okay. Now, sorry. Yeah, 0.54. Now to see the molecules, these are in molecular form. Multiplied by 6.02 times 10 to the power 23. Okay, then I get molecules. Let's do that one. 0.54 times 2. I get 3.25 times 10 to the power 23 molecules. But if you take this Si3Cl8, how many atoms are there in one molecule? 8 and 3, right? 11 atoms. So this number of molecules you multiply by 11, you get 3.25 times. I get my calculations. I get 3.57 times 10 to the power 24. Okay, then I multiply, I get 35. So I've written in the scientific form 3.57 10 to the power 24. So that's the answer I get here. Let's see again. Just to see. Make sure you use the calculator. Make sure that you have pressed the right buttons. You get the right answer. 361.9. I'm just using my full calculator. So that's how you get the answer here. I get about 3.59 near to, so more or less it is actually 4 times 10 to the power 24. Okay. The next question. Sorry, but just reading the question. Okay, there's another. The next question I have is determine the percent composition. The percent composition. So percent composition, okay, of oxygen. So they are given V2O5, and the molar mass of that is given as 181.9. So V is vanadium. Vanadium is 51. It's 51 roughly. So we have two vanadiums that give 51 times 102. Then oxygen, we have 5. 80. That's how you get. Okay. So it's 180 molar mass. So let me make it 182 because I'm following that as a percentage. So out of 182, oxygen is 80. So 80 divided by 182 times 100, I get the percentage. That is about 44%. So that's the answer, 44% or closest to it. Okay. The next question is just a simple one, molar mass of SF4. So what do? We find the values from the periodic table. Sulfur is 32, fluorine is 19 times 4. Then you get that there. 108. That's the answer. All right. The next question is again the molar mass of Ca5 PO4 3F. So each one, look at the periodic table and find. So calcium is 40 times 5 plus phosphorus is 31 times 3 because there's 3 here. All right. Plus oxygen 3 times 4, 12. 12 times 16 and fluorine is 19. So add all of them together and you should get the answer. Let's see, let me do the answer. See that? The answer is 504 grams. Okay. Right. The other one, how many moles of hydrogen are available in 0.75 moles of Na3PO4 12H2O. It's a hydrated solution, right? Like copper sulfate hydrated. You may have done this experiment, heating the copper sulfate, blue color become white color because the water is evaporated. Okay, so sodium phosphate here with 12H2O. They're asking how many hydrogen. The hydrogen is only here. So there are 12 because it's 12. This is a dot here, 12. That's how we write it. So 24 hydrogen. That's all I'm considering. Okay, in 1 mole. In 1 mole of this compound, you have 25. So in 0.75, you multiply it by 0.75. That is 3/4, right? So if I divide 3/4 means I divide by 4 and multiply, I get 18. So the answer is 18. 18, 1, 8. Okay. All right. Another question is similar to that. Again, asking how many moles of oxygen in 6.25 moles of Ba3PO4. Right. So let us just concentrate on oxygen because that's all they're asking. 4 times 2 means 8. We have 8 moles in 1 mole. 1 mole of this gives 8 moles. Okay. So then 6.25 multiply by 6.25, 8. Still not confused on that. So this is 8 oxygen. I'll write it like that. So 6.25, you just multiply 6.25 times 8. Right. How many grams of phosphorus? So they're asking again, grams of phosphorus in 3.5 of E4O10. Okay. Now they are given the molar mass because we need the gram. So 3.5 moles. All right, let us see. So I'm thinking of the best way to do it. So I would take this as in 1 mole, let us say. 1 mole of that compound will give 4 moles of phosphorus, right? So 3.5 would give 3.5 times 4. 3.5 times 4, you have to select the easiest way for you. That's 14 moles. Then if I multiply by the mass of phosphorus, I should get the mass of phosphorus is 31. 31. Sorry. Times 31. I get 434. Okay, then again, how many grams of Cl in 3 to 5 grams of SbCl3? Okay, so we have to see how many moles are there first. So they have given the molar mass of SbCl3 as 228.10. So you divide 3 to 5 divided by 228.1. Get 1.42 moles. They're asking the grams. Yeah. So 1 mole of this has 3 moles of Cl, right? So if I multiply by 3, 1.42 times 3, I get 4.26 Cl. For the gram, you multiply by the molar mass of chlorine, which is 35.5. Then I get 151.23. So nearest value is the right answer. Okay. How many molecules of NO are present in 7.5 moles of NO? You see, you will see that what I did exactly the similar question. So I'm doing again because that's what these questions are. Okay, the practice questions we are doing here. So 7.5 moles are present in how many molecules are present? So just 1 mole will have the Avogadro number, so 6.22 should give the answer. Roughly 4.5 instead of 24. Okay. I don't know whether we did it before, but molecules, how many molecules are there in Si3N4? How many molecules of Si3 in 850 grams? How many molecules of Si3N4 are in 850 grams of Si3N4? Okay. So first find the number of moles. 850 divided by molecular mass 140.28. They have given it. So Si3N4 mass is given as 140.28. Okay, that's right. Put it here. So 850 divided by 144.28. I get 6.059 moles. That's the molecules, right? So multiply by 6.06. So 6.059 is the moles. Okay, so let us say, okay, I'm not going to run it. So I multiply by 6.02 times 10 to the 23. I get 6.05 times 6.02. I get 3.64 times 10 to the power 20. When you know the patterns of questions, you should be able to do the same because the method you're going to use the same. The theory, the knowledge you're applying is the same. So it should be easier and easier more you do that. How many atoms of nitrogen? Now here they're asking the atoms. We did similar ones before, atoms of nitrogen. So you should be able to do it by now. Before I do that, in 185 grams of N2O. How many atoms are there in that, right? So 100, okay, this is slightly different. They're not asking how many atoms of N2O are there. They're just purely asking nitrogen. So let us see. They have given the molar mass of N2O as 44. I'm just writing the rounded up or down value. So 185 divided by 44, you get the number of moles. 185 divided by 44, you get 4.2 moles. In how many molecules are there? So you multiply by 6.02, 10 to the power 23. 4.2 times 6.02, I get 2.52 times 10 to the power 24. Now in N2O, you get 2 atoms of nitrogen. See, so earlier if they has how many? 3. If you have the total atoms, but they're asking only nitrogen, so 2. So it has to be twice of that. So 4, 3, sorry, 5 times 24 would be the closest answer. Okay. All right. The next one is determine the percent composition. Again, percent composition of Na2Cr2O7. Percent composition of oxygen, sorry. Percent composition of O in this Na2Cr2O7. They have given the molar mass as Na2Cr2O7. So it's easy for us because the molar mass is 262 grams. Out of these 262 grams, oxygen, there are only 7. So for oxygen, 7 times 16. Okay. So 7 times 16 would be 112. So 112 of O are in the whole one. So 112 divided by 262, the entire mass, times 100, you should get the percentage. I get 42.7%, so we can say 43%. Okay. All right, I'll do 2 more questions on then most important questions that get whatever things you can gather on. The detonation of nitroglycerin. Who bombs nitroglycerin? So reaction is given. nitroglycerin is given as 4C3H5N3O9 12CO2 plus 6N2 plus oxygen plus 10H2O. Okay, what they're asking, what type of reaction? You can see the one compound has dissociated to that. So it is decomposition. Decomposition. Okay. All right. The last one is they're asking what type of a reaction is this type of reaction. That's in Na2CO3 plus PbNO3 to 2NaNO3 plus PbCO3. Sodium replaces this. Sodium is replaced by lead. Lead is replaced by sodium. So this is a replacement. This is double. Okay. All right, everybody. So if you carefully pay attention to the questions I've done and repeat and see the questions, you will do well.